Welcome to our video presentation. Our group is called SnapRoster. We are currently researching facial recognition systems, and we are determining whether or not these systems can positively affect operations of institutions in the Caribbean. Our team consists of 3 members: Vanessa Boudram, Brandon Francis Mohammed, and Damian Jawahir, and we are all similarly enrolled in the Information Technology program. Therefore, we have similar interests, and working on this project was very fun. We hope that you thoroughly enjoy listening to our presentation as much as we enjoyed creating it. Firstly, I'd like to describe facial recognition. Facial recognition captures a person's image and analyzes the geometry of a face to store a facial signature. This signature will be stored in a database and will be used by deep learning algorithms when matching facial records for the purpose of authentication and identity verification. This way of recognizing humans through technology seems like a perfect solution to resolving the problems that organizations usually face on a daily basis when it comes to retrieving accurate data regarding punctuality and issues like attendance. The purpose of this research project is to determine whether facial recognition is an ideal solution for attendance recording within the Caribbean, given our diverse culture, where people of different religious backgrounds and race often interact. Basically, we would like to determine the compatibility of the software in regards to our general ethnic diversity.
Here are some of the problems that SnapRoster addresses. Attendance recording is usually done on paper or by scanning a QR code. This traditional method is manually done, which makes it time-consuming. The accuracy of the data is often compromised as students or employees would sign or scan for both themselves and someone that is not present. Another problem addressed is with the data collected. It is usually unorganized and only accessible by one person at a time. Analyzing the data collected after a period of time is quite difficult because it requires additional tasks to be done before any reports or summary can be done, whether it is to determine if a student met the required attendance for the semester or the attendance of an employee to calculate their salaries. Here are some of the solutions for the problems addressed when SnapRoster is implemented. The attendance recording is now automated. The system is now foolproof since it requires them to be present to scan the individual's face. The automated system will store each record in a database where multiple individuals can access it. Since SnapRoster is connected to a database, additional features such as generating a report or sending alerts can be done.
Our group has paid close attention to the advantages and disadvantages of facial recognition and have condensed facial recognition into these key attributes. Firstly, it facilitates the moving away from a physical means to an electronic one, making the verification of users faster than, for example, a student identification card. Secondly, it saves time in situations where there are a large number of data or users which need to be processed in queue. Thirdly, data can be automatically input into a database and with a greater accuracy than a human. And finally, with the talk of hygiene in today's modern media, it is very important to note that facial recognition is very hygienic, given that there is no need for most users to physically interact with the system. Secondly, we move on to the goals of facial recognition, which have been found through our research of what are the best uses of facial recognition as an attendance system. These are to automate the attendance recording of a user, to record the data accurately, to alert an administrative user if a user has been absent for a prolonged period of time, and to minimize the distraction and time consumption when recording attendance of a user. Thirdly, based on the goals of our research, we have obtained several objectives. These are to research the development of a facial recognition system that automates all role-taking procedures. The system should also reduce any inconvenience to the lecturers, students, or employees or other personnel. It should be as simple as mounting a mobile phone or tablet to an entryway that allows the system to automatically scan individuals. And finally, the data collected should then log all information about users which are relevant into a database.
The Snap Raster system is designed for it to function as an everyday task, meaning it would be frequently used while constantly storing and retrieving data. Data captured from the photo comparisons are stored locally on the system's device and then later updated to the online database as connection is available. This acts as a safety measure in case the device has internet connection problems. There are multiple feedbacks to notify the general user when the facial signature is captured. These notifications are intended for all abilities. For example, audio notifications for the visually impaired. Admin panel is simple and accounts for large quantities of requests, such as performing simple queries.
For our system design, the components which we have decided are necessary for the system are 1. An interface for administrative users to add new users and view existing user records and generate their reports. Second, a camera for facial mapping. Third, a comparison module to match persons to images on the database. Fourth, a component to log date and time information of general users. Fifth, a database such as MySQL to store user information. Sixth, local or online storage such as a hard drive or cloud storage to keep the user's data. And 7, a backup power in the event of a power outage so that the system may still function. Based on our goals and objectives, our group has decided that this will be how our system will be put into place. So first we will start with a user. The user will then be scanned by the system, and then they will go to the user records. From the user records, the system will have one of two options. Either the user is not found, and if the user is not found, then the user will have to contact the office for further information as to what to do, and then the office will respond with them and tell them what to do. Secondly, the user records can confirm the user, and when the user is confirmed, their login date and time will be recorded, and then their logout date and time will be recorded when they decide to leave the room. Afterwards, their attendance will then be recorded, and it can then go to secondary analysis data and other systems, and afterwards a report can be generated about the user, which can then go towards the user's pay or other types of systems which the company or university may have in mind, and then it will move towards the end of the cycle of the system.
Introducing our Snap Raster facial recognition attendance system demo. This demo will give you a preview and a vision of what our application would look like when it comes to life. It shows main screens, how it's laid out, and the features it will provide.
like to discuss tests which we were unable to complete due to constraints which will be discussed later. First, we wish to test persons using off-the-shelf systems in different room conditions, such as different levels of light and different camera angles. Second, we would have liked to test users several times but have them change their physical appearance, such as their makeup or hairstyle. And finally, test persons who are using articles of clothing which obscure the face. All of these tests would have been conducted to see if off-the-shelf facial recognition systems would be able to identify people given these challenges. Given the system which we are creating, we have outlined specific criteria which need to be met. These are the ensuring that the system is modular to allow integration of other software, fast and reliable hardware. Tests must be conducted with various ethnic groups to ensure the system will function in its target market, testing of a large database to ensure speed and reliability, and the system must be scanned with random variables to ensure functionality within the real world.
The global impact of the COVID-19 virus severely hindered the project deliverables, and an inability to form the desired focus groups caused unintended discrepancies in testing. Some of the affected features were the use of existing software to test the focus groups, using gathered data to verify other studies, determining the most consistent hardware after testing, and the cost versus consistency comparisons. Our research methodology consisted of surveys and existing data extracted from online sources to gain a greater understanding of the ethics and views persons may have had on facial recognition. The survey was conducted using Google Forms, which allowed us to distribute the survey online. The various studies used originated outside of the Caribbean, so while the data may have been valid, it did not accurately reflect our ethnic backgrounds and cultural diversity. After gathering the data, we used charts generated by Google Forms and raw data to analyze the information. Both positive and negative aspects were evaluated, with the main focus being on the key concerns and issues of the potential users, as this was most relevant to the research being conducted.
Based on the information we gathered, we can analyze the results to learn the following. Facial recognition systems are very accurate under the right conditions. While the system is accurate, the cost of the system is based on the quality the customer wishes to get. For example, a better camera or processing power costs more but speeds up the system significantly. The system speed being dependent on the hardware means physical barrier needs to be implemented. As such, we recommend a turn-sill or automatic door to filter the users into the room only when verified by the system. After analyzing the data collected, we found the following. Security seems to be one of the greatest concerns that users have with using a facial recognition system, since it requires storing their image. Some of the responses shows that the users believe that it's an unsecure method of verification. Many users believe the system is adequate to be used as a primary verification system, as the technology is accurate enough to be deployed without issue. A few users admit encountering errors while using the system. However, in many other circumstances, the system was proven to function effectively and accurately.
Future plans for the research project includes testing of off-the-shelf systems and the development of a live prototype for testing purposes. Expansion on the research covered can include improving the technology by mapping more defining facial features, and also by incorporation of an infrared system that can take the thermal image of a user and overlay it onto the scanned camera image to increase the accuracy levels in the facial recognition process.
While we were unable to properly test our system due to the COVID-19 pandemic, we have determined that there is strong enough evidence that a facial recognition system should see a large amount of success in the Caribbean. However, further testing must be done as to how accurate the system will be for use within school systems in the market, Due to the cost of infrastructure as well as the difficulties the system may face, scanning persons of differing ethnicities.
Thank you all for viewing our presentation, and I'd like to wish you all a very good day.